Imagine an aircraft that takes off from a runway like a normal plane. Okay.
That's right.
But then it flies straight into orbit, more like a rocket. Just think for a second about what that could actually do for travel, for defense, even just accessing space itself. Okay, so let's unpack this a bit. Today, we're doing a deep dive into a project that promises exactly that. It's a European initiative called Invictus. We'll explore why Europe is betting on this, the really fascinating tech making it possible, and what it all might mean for the future of flight and space. Our mission here is to cut through the noise and give you the key insights from our source material. That's an article from space.com by Mike Wall, published literally today, July 17th, 2025. So first off, why Europe? Why hypersonic space planes, and why right now? It really feels like they don't want to get left behind here.
Well, that's right. And what's really interesting is that this isn't just blue sky thinking. The European Space Agency, ESA, they're actively funding this. It's a Pathfinder project, so it's definitely a strategic move.
Strategic how? What's the bigger picture for them?
Tommaso Guidini, he's the head of the mechanical department at ESA. He put it very clearly. He said, and I'm quoting here, "Hypersonic flight is not just the next frontier of aerospace. It is the gateway to a new paradigm of mobility, defense, and space access."
Wow, a new paradigm.
Yeah, it makes you ask, what kind of future is Europe actually trying to build by leading in these specific technologies?
Right. It sounds less like just faster planes and more like fundamentally changing how we get around the planet. And off it. Laying groundwork. But, okay, this sounds incredibly difficult. How does a plane just go orbital from a runway? What's the secret sauce? The core tech.
The absolute core innovation here, the real key insight, it's a piece of tech called a pre-cooler. Now, this isn't brand new out of thin air. It's actually being leveraged from Reaction Engines Ltd. You might remember them.
The British company. Skylon. Yeah, I remember hearing about that. They went bankrupt last year, didn't they?
That's the one. They had huge plans for Skylon, their giant space plane concept. The pre-cooler tech comes from that effort. So folks from Fraser-Nash who are involved in Invictus now, they explain that at hypersonic speeds, we're talking more than 5 times the speed of sound, Mach 5 plus. Aircraft face just immense heat. You get shock heating, air friction. It gets incredibly hot.
Okay.
And conventional jet engines, they just can't handle those kinds of temperatures. They'd melt or fail.
So the pre-cooler solves this fundamental heat problem. That's its job.
Exactly. It cools the air before it even gets into the engine. Radically cools it incredibly fast.
How fast are we talking?
Think dropping the air temperature from maybe over 1,000 degrees Celsius right down to ambient sort of normal temperatures in just a tiny fraction of a second.
Whoa.
Yeah. And that crucial step is what lets you use engines that are closer to, conventional jet engines, even at those crazy hypersonic speeds. And linking it back, this pre-cooler was originally part of Reaction Engine's big idea, the Sabre engine.
Right.
Synergetic air-breathing rocket engine.
Sabre, right? I remember that name.
That engine was designed to be a hybrid. Part jet, part rocket. It would actually breathe air, pull oxygen from the atmosphere at lower altitudes.
So it doesn't need to carry all its own oxygen from the ground up?
Precisely. For the atmospheric part of the flight, anyway, that drastically cuts down the amount of heavy oxidizer you need to lug into orbit. Big boost for efficiency.
That really does sound like a game changer. Okay, so this Invictus project, using this pre-cooler tech,
yeah.
How big a deal is it? What's the funding, the team, the timeline look like?
Well, in terms of the immediate money, it's not, a mega project just yet. It's £7 million sterling.
Which is about?
Roughly $9.4 million US dollars, give or take with the exchange rate. But ESA clearly thinks it could have a really significant leverage impact on European space capabilities down the line. The work itself is being led by a consortium. Fraser-Nash is heading it up, but they've got partners like Spirit Aerosystems, Cranfield University, others involved too.
And what's their first goal?
The plan is pretty ambitious for the first phase. Within just 12 months, they aim to deliver the concept design, the preliminary design work for the whole flight system.
12 months. Okay.
Yeah.
And the actual vehicle, the thing that flies, when could we see that?
The end goal is a reusable vehicle. And yes, key point, takes off from a runway, lands on a runway. Just like an airplane.
Maximum flexibility there.
Exactly. And if everything stays on track, the target for having it up and running is by early 2031.
2031. That feels soon for something this complex.
It is ambitious, definitely speaks to the drive behind it. But think about the versatility of a vehicle like that.
Oh, absolutely. If it can do runway to runway and go to orbit,
yeah.
The potential applications, civilian, military, science, must be huge. Tony Forsyth, UK Space Agency's head of space tech, he's quoted, pointing to economic growth, national security benefits.
Makes sense.
So is Europe kind of going it alone here? Or is this part of a wider trend? Are space planes making a comeback?
Oh, it's definitely a broader resurgence. It's quite striking, actually. You know, we had the most famous one, NASA's space shuttle, retire back in 2011. For a while, it felt like maybe that concept was done.
Yeah, it seemed that way.
But now, they are absolutely back on the radar. And Invictus isn't even the only European effort. Just last month, you had the French government and Dassault Aviation announce their plans for a demonstrator called Vortex.
Okay, so competition even within Europe.
It seems so.
Yeah.
And then globally, well, the U.S. military has been flying the robotic X-37B orbital space plane for years. Very hush-hush, mostly.
Right, the mystery machine.
And China has a similar vehicle, too, the Shenlong. Also robotic, also quite secretive.
Okay.
And don't forget the commercial side. Virgin Galactic is already flying passengers and researchers on its suborbital space planes, Spaceship Two.
That's true, suborbital, but still a space plane. And the article mentions others too, doesn't it? More companies jumping in.
Yeah, absolutely. Get this. Sierra Nevada Corporation with their Dream Chaser, which is actually getting ready for cargo missions to the ISS soon.
Dream Chaser, right? Looks like a mini shuttle.
Then there's Dawn Aerospace, Radiant Aerospace, several players developing different concepts for reusable space planes.
So it's not just Invictus. It really does feel like a global pivot, or at least a renewed interest in this whole space plane idea. Okay, so let's sort of recap. We've dug into Europe's Invictus project. We've seen the big ambitions behind it, redefining mobility, defense, space access. We looked at the clever pre-cooler tech borrowed from past efforts that makes the hypersonic air-breathing part feasible.
That critical piece.
And we've placed it in context. It's not happening in a vacuum. It's part of this global resurgence of spaceplane development.
Right. It really seems like mastering this kind of reusable air-breathing propulsion is seen as foundational technology for the next era of aerospace, potentially.
It really does feel transformative.
Yeah, the implications go way beyond just, getting from A to B faster.
So as we wrap up this deep dive, here's something to think about, maybe something for you to chew on. If these aircraft can really do it too, take off like planes, reach orbit like rockets, and come back again, making both long-haul travel and space access much more flexible, maybe cheaper, what new possibilities does that unlock for your future? What kinds of industries could pop up? What kind of travel might just become normal? And how does our whole relationship with space change when getting there isn't quite such a monumental single-shot event?